Welcome everyone. In this week, we will do the Lab 3 in EE200. Okay, you can start.
Okay, I will build an RC circuit today. I have 10 kilo ohm resistor and 10 nanofarad capacitor, and I've connected them like this. They're connected in here, and I'm applying the positive side of the function generator to the resistor's leg, and the negative side of the function generator to the capacitor's leg. And as you can see, this cable is the input to our circuit right now. And to measure the input, okay, first let's apply the input. I will turn on wave generator, and I set the waveform as sine. You can like set it here, and I will set the frequency as 1 kilohertz. Let's start from 1 kilohertz. Okay, and amplitude, I can change the amplitude, and in the lab manual it says apply 5 volt peak to peak right now, and it's like blue, so it's applying right now. And to measure it, I will like put the first probe, first channel as input, and I will put it here and connect the negative side here. Okay, this is the first channel, and to the second channel I will connect. Let's make sure that this is the second channel, and I will connect the output. I will take the output from the capacitor, so I will connect this into the capacitor's leg, and I will connect the negative parts together like this. Right now, three of them are connected here. Okay.
Okay, first of all, do you see 5 volt peak to peak at the input?
Yes, let's see. So our division is 1 volts, and you can look at the divisions, and I've clicked these measurements beforehand, and we are seeing like 5.11 volts peak to peak. I set to 5 volts, but there can be small errors in this, and a maximum of 2.52 volts, like its peak it gives us. So it's correct, and I cannot see the output right now because I have not opened the second channel. So I clicked on the second channel, and their divisions are 1 and 1. This way we can see their amplitudes. And the peak to peak of the second channel, I mean the output is 4.1 volts.
Okay.
Just like this.
Why is the output voltage is so high?
I mean the output is a bit lower from the input because it's like it's an RC circuit. It behaves like a low pass filter. So we applied 5.11 like in the input, but we are seeing 1 volt less.
Okay. So since the frequency you have applied isn't so high, and this circuit is a low pass filter,
yes.
So you are saying there is a minimal voltage drop.
Yes, right. And I can like decrease the frequency further to see like what happens. I mean, if I like decrease it down to 500 hertz, so it seems like they are nearly equal, and the output is 4.8, something like 4.8. If I even decrease further, let's go to 10 hertz, and I'm just adjusting the horizontal. So as you can see, the output is 5.07 volts, and the input is nearly the same as the output. So I mean this is definitely a low pass filter, and I can look further in the frequencies like higher. So we were first. I'm just increasing the frequency and adjusting the horizontal view to see the.
I can help.
Yeah, okay, thank you.
Increase the frequency.
Okay, I'm increasing it. It's increasing, and as you can see, like the green one, the output is decreasing with increasing frequency. I'm at 5 kilohertz right now, and the peak to peak of the output is dropped below 1 volt. So if I further increase the frequency, let's get up to 10 kilohertz. Yes, at 11 kilohertz, the reading is 400 millivolts. Very small value. And if I even decrease it further, increase the frequency further, the output will become smaller and smaller. Okay, and for the phase, I've added phase to the measurements. From the measurement menu, I've selected the type of measurement, and I've selected phase from 2 to 1. Let me close this, sorry. 2 to 1 and 1 to 2. I mean, we should look from 2 to 1 because we are looking from output to input. I mean, V out over V in. And as you can see, it has 288 degrees phase difference. And it corresponds to the minus 70, like something like this. So from looking at the phase 1 to 2, I mean input to output, we can just take the negative value of it. So let's sweep the frequencies again and see how phase is changing. I will start from very low frequencies, like 200 Hertz. Okay, let's adjust the horizontal. Now the phase difference is like 10 degrees. And as we go further in the frequencies, like with increasing frequency, the phase difference is increasing, as you can see.
Okay, just
but
increase it more.
Yes, but to the negative values it's increasing. Because we are looking at the negative of 1 to 1. Okay. And now we are at 5 kilohertz and the phase is around minus 90 degrees. Now, so if I further like increase it, it will further increase. This is the phase plot.
Okay. And now you can continue with the part 2.
Okay, we are at the second part. Now I've added an inductor to our circuit. Now we have a resistor. It is 100 ohms, and a capacitor. It is 470 picofarads, and an 8.2 microhenry. Yes, microhenry inductor. And again, I'm connecting the function generator the same way as before, like this. And I will again, as we can see, we are trying to measure the capacitor voltage and the inductor voltage, but in the lab it asks us to measure from capacitor's leg to inductor's leg, and only the inductor. So I will connect accordingly. Now I will connect the first channel.
The first channel goes to the capacitor.
Yes, okay. One probe, the positive part, will be at the capacitor, and the negative part will be at the ground. I will connect the jumper to it. Okay, I will connect them like this. And the other one, the second channel, will be from the inductor's leg. And again, I will use another jumper to connect their grounds together. It got off. Yes. Okay. Like this. Okay. Now I should be able to see the waveforms. I will first apply a wave generator. I will apply, I think, a sine wave.
Yes.
Okay. And I will set the frequency as 1 kilohertz again. Like, let's start from 1 kilohertz. And it is 5 volts peak to peak. And I will turn on the channels. Now this is the input. The first, not the input, sorry. This is the voltage.
On both
yes.
capacitor and inductor.
Yes, the capacitor and inductors. And the second one will only be the inductor's voltage. Okay. At 1 kilohertz. Okay, I am seeing a very little voltage drop at the inductor and a high voltage drop at the capacitor right now. No, they're both of them, I mean. So we are not really measuring the capacitor alone. So to do this, I can use the math function of the oscilloscope, and I should subtract the second channel's voltage from the first channel to only have the capacitor's voltage. So from the math,
Yes.
here's the math, and I will select the operator as subtraction,
Yes.
and this it is FT is written as channel 1 minus channel 2, and that's what I'm looking for from source 1 to source 2. This means like that, and I will.
Yes, actually
Okay, yeah.
Subtracting, but since the green waveform is very small, pink waveform, which is the new matte waveform, is very similar to the waveform of the channel 1.
Yes. Okay, now the channel 1 is like on top of it. As you can see, I will change the scale. Okay. The scales are. Okay, right now, so I have the inductor's voltage alone, the capacitor's voltage alone, and the total of them in both channels and the function, math function. So I think we should sweep the frequency right now.
Yes.
So let's open a generator and select frequency. I will first decrease our frequency, see what happens.
Actually, decreasing it doesn't change the result because the frequency you have applied was very low
Yes.
at the beginning, and we see no change in the behavior. So maybe you can increase the frequency to see what happens.
Okay. Okay, let's increase the frequency and let's observe what happens. And we are adjusting the horizontal view as we increase the frequency.
Do you remember the resonance frequency that you have calculated?
Yes, we are calculating the frequency at 2.5 megahertz, I think. So we are at 0.5 megahertz right now. And I observed that the green voltage, which is the inductor's voltage, is increasing. And as you can see, other one is decreasing. And I'm at 2.4 megahertz right now. And we are losing the trigger right here. So I will adjust the trigger. Okay, this is fine, and I will set it for source 2. I think it's also okay.
It's okay, yeah.
Yes, let's increase the frequency. Okay, so again the channel 2, which is the inductor's voltage, is beginning to decrease, I think. And at this point, at these points should be our resonance. I think.
Yes, just find where yellow waveform is the smallest.
Yes, I think it is smallest at 2.7 megahertz. It is coming as 700 or 800 millivolts. It's reading, and as we can observe, the yellow one was the addition of both. So if I close it, I can observe that this purple one is the voltage on the capacitor, and the green one is the voltage on the inductor. So at resonance, we are expecting them to cancel out each other. So as you can see, their peak are nearly equal, their magnitudes are equal, but they have a phase difference of 180 degrees. So when they add up, they should ideally be equal to 0, and that's what we call resonance. But I mean, because of the non-ideal effects that we are currently measuring, the total of them are small but not 0.
Yes, that's all for this week's EE200 Lab. Well done.
Yes, thank you.